Hello everyone. I hope everyone is staying healthy and happy. This video lecture is for the topic of functions as objects. So this idea that functions are objects is extremely radical. So why exactly is this radical? It could have a lot of crazy implications. For example, variables in general are supposed to contain references to objects. Since functions are objects, variables can now contain references to functions also. Parameters are special variables which are defined as part of the function definition. Now, parameters can contain references to some other functions. Lists and dictionaries also contain references to objects, hence they can also now contain references to functions. All sorts of such crazy combinations are possible because of the fact that functions are objects. Take a few seconds to actually look at this particular example over here and pause this video here and try to answer the following question. Which one of the following lines of code is crazy and it is something which you haven't seen before now? So, if you were thinking of the line G equal to F, you're perfectly correct. So, let's take a look at this example step by step and look at what exactly each of these lines stand for. So the first line is actually creating a list object on the heap memory with items 1, 2 and 3, and it is creating a reference to that object inside a variable called x, which is going to get populated onto the stack. So the next line of code is actually creating a reference copy. Quick recall of what a reference copy is that it only creates a new variable, but it still refers to the same object as before. So y is going to still refer to the same object in the heap memory. So the next line of code here defines a function f. Since I just mentioned that functions are objects, what this definition is going to actually do is that it's going to create a reference in your stack which is named f, and that's now going to refer to the function object for this particular function definition. We have seen such structures in Python tutor, but so far we have ignored what exactly it stands for, but today's lecture is all about understanding what exactly those representations are for functions as objects. Alright, so the next line is actually the crazy line in this particular set of code. So what exactly is it doing? I'm just assigning the reference to the function f into a new variable called g. Once again, this is a reference copy. So what is g going to contain is that it contains a reference to the same function object. So the final line of code is invoking the function f. This isn't anything new. What would happen now is that a new frame gets created for f, and out of that particular function execution, it's going to return the string object hi, which is now going to get assigned to the variable z. A reference to the string object hi is going to get assigned to z. So in this particular image, I'm not showing the frame for f, but you can imagine a new frame gets added and then gets destroyed after the function call. So there are two different ways that you could have called the same function here. That's because G actually contains a copy of the function reference. So both of these lines mean exactly the same thing. You can call the same function by using the function reference name f, or the newly created variable for the function reference, which is g. So if you take a closer look, you'll find that the list initialization and the function initialization is something very, not function initialization, function definition is something very similar. Both of these create objects, but the main difference being the first one creates a list object and the next one creates a function object. And the next thing that you'll notice is you have two different reference copies, both of which are quite similar. The first one creates a reference copy for a list, and the second one creates a reference copy for a function instead. An important thing to notice is that these two lines are entirely different. So what is so different between them? So notice that there are no parentheses when I actually assign the reference to a function into another variable. Whereas when there is parenthesis, I'm actually invoking the function. So without parenthesis, I'm referring to the function as an object, and with parenthesis, I'm actually creating a function invocation. So I'm going to actually get started with very simple demos to understand this whole concept of functions as objects. And then we'll move on to meaningful demos. All right, so let's define a simple function which let me call it as say hi, and I'm going to print hello inside the function. And suppose I define another function called say bye, and inside that I print wash your hands and stay well, bye, which is very apt to the current situation. I hope all of you are thoroughly washing your hands. And let's say I want to call the first function 2 times and the second function 3 times. Alright, so let's actually step through from the first over here. So what happens when you define a function is that inside the global frame, a reference to the function with the function name gets created, and it actually refers to the function object. And the same thing happens for the say underscore by function as well. So when the function invocation happens, as usual, a new frame gets created for that particular function call, and the print occurs, and once the function call is done, the function returns none, and you move on to the next line of code. Similarly, stepping through, you'll be able to see the output that gets generated by calling these functions these many number of times. Alright, instead of just calling the functions as such, what if I now assign the function reference to another variable, say f, and instead invoke f? So I can do fancy things like I can reassign this variable to another function reference and do the same invocation as before 3 times. Let me step through from the first again. So once again, the function objects get created in the heap, and the references get created using the function name on the stack. So let's see what happens when we create a copy. So notice that f now points to the same function object as say hi, and once you invoke f, it actually invokes say hi, and if you keep stepping through, it will print hello twice, hello there twice. And let's see what happens now. So I'm reassigning the function reference for the variable f to another function reference, which is the reference to the function say by. So what happens now is f now switches to point to say by in the heap. And let's see, so we once again when you call f, it will now call say by, and it will go ahead and print wash your hands and stay well 3 times. All right, so uh, notice that when I'm assigning the function object into another variable, I am not actually using the parenthesis. So let's actually go ahead and add the parenthesis here, and let me step through from the first. I want to talk to you about what happens when you actually incorrectly add the parenthesis when you meant to not add them. So let's see. So once again we have two function objects in the global frame, two function references in the global frame which point to the corresponding function objects. And then if we do add the parenthesis, I'm actually invoking the function. So what would happen when I invoke the function is that say hi actually returns nothing, and it returns none because we are only doing a print. So note that f is now going to contain none because we are assigning the return value of say hi to f. So what would happen to the next line is that Python cannot actually call a function when clearly f is a reference which contains nothing. And that's why you need to actually focus on the fact that uh, there won't be any parenthesis when you're trying to assign the function reference to another variable. All right, so what if instead of calling this function over and over again, I want to write a loop to call this function a specific number of times. So let me replace this snippet of code with the corresponding loop. So we had the first function called twice, so I'm gonna say for I in range 2, and I'm just going to invoke the say hi function. So as we can see, it does work and it gives two hello there prints. So similarly, I can just say for I in range call say by function 3 times, and as you can see, it prints out wash your hands 3 times. What if I want to write a generic function, say call n times? Think about what sort of parameters do you need to have to be able to repeat this particular functionality. But keep in mind that this should generally work for both the functions over here. So pause the video here for a minute and think about what parameters you need to define for the call n times function. We need two parameters, the first one being which function exactly to call, and let me define that parameter as f. And the next parameter is a number n, which tells you how many number of times that particular function needs to be called. So clearly your loop range should be based on the parameter n. So what you need to call repetitively inside this loop is you need to call the function f. Let's see. So to repeat the same functionality as before, I need to call the call n times function with the reference to the say hi function, and that needs to be invoked twice. Similarly, I can invoke the call n times function with say underscore by function reference, and I'm just like calling that function 3 times. As you can see, now we do get the same print. So let me step from the first, step through from the first. So we go ahead and define two functions and corresponding references to those function objects. So the third function that gets defined is the call n times function, and as you can see we have a call n times function reference. So what would happen when we invoke the call n times function is that uh, to the function's parameters, we are passing the arguments as say underscore high function reference and the number 2. So as you can see, the first argument is sort of like pointing to the function object which is given for the function say underscore high. So when you step into the loop and you invoke the function f, you're actually calling the function say underscore high, and similar to the previous invocations, that's gonna result in printing hello there twice. And similarly, if you keep stepping through, you'll see that it prints wash your hands thrice. All right, so these are just simple examples. So I'm going to actually switch to Jupyter Notebook now, and let's take a look at a couple of more detailed examples. All right, suppose you have a list L which contains a list of uh, integers but in the string format. For example, say the list contains these three items. So think about why such a list would actually exist. There are two different scenarios where this could possibly happen. Pause this video here for a minute and think about why and what sort of scenario would actually cause you to have a list of numbers which are each in the string format. So the first way that that could happen is because you're reading the data from a file. So recall that whenever you're reading data from either a CSV file or a JSON file, your data that comes out of it is always going to be in the string format before you actually go ahead and typecast that to whatever is the correct format that you need. The second such scenario would be that you're processing command line arguments. Recall that you need to use the sys module to process command line arguments, and command line arguments are sort of given by the special list which is called by using sys dot not called, which is which can be referred by using sys dot argv, which is the special list containing the list of command line arguments. Recall that your command line arguments, no matter what you pass when you invoke the function in the script mode, it's always going to contain a list of strings and before you go ahead and do the typecasting. So clearly we have a need for let's say typecasting such a list to integers. So let me go ahead and define a function called apply to each, where I'm going to actually typecast each of the list items into integers. So what am I going to do in this function is I'm going to take the list, and let me actually define the parameter for the list as original list. And before I do anything, let me actually go ahead and write a loop for val in original list, and I'm just going to go ahead and print val. So let's first test this, and let me call the function with L. All right. So the basic structure of the function does work, and let me see. So what do I want to do here is I want to be able to convert each of these values in this original list into an integer. And the way that I'm going to do that is I'm going to actually uh, do some form of transformation inside my for loop for each of these items. And let me go ahead and define another list here, empty list here, which I'm going to call new vals. So for each transformation that I'm doing inside my for loop, I'm going to actually append the value into my new vals list. So what am I going to do here is that, let's see, so I want to append to new vals, and for this particular example all that I need to do is I need to convert my each of my value into an integer. So I can go ahead and typecast each of those values into an integer, and let me go ahead and return new vals, and let me capture the return variable in this function call. So if I go ahead and run this, and let me display what's going on with vals. So as you can see clearly, each of those objects got converted into integers instead of the original values which were strings. Alright, so let's make this apply to each function a little bit more generic. What if I want to do more manipulations and I want to be able to control what exactly is the function call that is happening over here? So let me pass a function reference to this function. So I'm going to go ahead and invoke whatever function reference is being passed to me instead of just doing a typecast using the integer function call. So what you need to do now, let me actually switch around the order. Right. What you need to do now in order to call your apply to each function is that you need to pass as arguments to your function what list you want to go into this positional argument, and what function needs to go into this position. So let me go ahead and pass the reference to the int function. So if I run the code, the behavior should exactly be the same now, because we haven't done much other than the fact that I replaced the function, uh, reference here as a parameter to my function apply to each function. Hopefully that makes sense. All right, so this is one such example of the apply to each function, right? So let's make it a little bit more tricky by saying we are defining a new list now. So let me go ahead and redefine list L. So this must be familiar to you. What if your list actually contained um, few items which had dollar at the beginning of each of those items? Suppose your transformation should now handle taking care of this initial dollar, get rid of it, and then it should go ahead and convert this string part of it to integer. So let's see how exactly we can do that. So let me go ahead and define a new function called, let's see, strip dollar, and suppose it takes in a string s, and what we need to do in that string is remove the beginning dollar sign from string s. That's the objective of this particular function. So this can be done in quite a simple way, right? We can just check if that particular string s starts with a dollar, and if it does starts with a dollar, then you can simply let's say return s from the first index position, leave out the 0th index position in your string, and return just the rest of it. So let me actually go ahead and save this into S so that I can return S in both the cases. In the case where your string actually starts with a dollar, your if condition gets evaluated to true, so this line will get executed. Whereas if your string doesn't contain a dollar, then you return the string as such. Alright, so let me actually go ahead and move this cell up so that I have this function definition before my apply to each function. Alright, so what we need to do now is we have a new list L over here. What we need to do is we need to call apply to each function on L. Instead of directly calling the int typecast function, what we need to do now is to call the strip dollar function, and let's see what is getting returned. Oh, apply to each instead of apply each, sorry about that. Okay, so as you can see, the function does successfully strip the initial dollar, and it returns all of the values which are still in the string format. So suppose you want to convert all the string format. Let me go ahead and change this to a print. Suppose you want to continue transforming this data, and say you want to add the conversion which converts to integer. So let me go ahead and repeat this particular function call. If I go ahead and run this, oops, okay. Oh, sorry, I passed L instead of passing val, so let me fix that. So as you can see, we have a two-stage transformation now, which is exactly how you can make use of the fact that you can pass references to functions as a parameter to another function. So your apply to each function is now generic, and it can be used for two different transformations based on whatever function reference is being passed to the second parameter here, which is f. Hopefully this example makes sense, especially if you're a programmer who doesn't like to write a lot of loops and prefers to work with function instead. The fact that functions are objects, and the fact that you could actually pass references to functions as parameters to another function is quite enticing, and you can write such generic functions which enable you to do a bunch of transformations. Alright, so there is this one last thing which I want to demonstrate with this particular example, which is the fact that you can actually pass references to methods as well. So let's actually go ahead and define a new list for that purpose. Suppose I have a list containing actual set of strings, and let me create three different items. So suppose I want to be able to convert each of these items into uppercase string. The way that I can actually invoke the same apply to each function is, let me pass L because I just redefined L, and the function that I want to be able to apply to each of those list items is that I want to actually invoke the method upper. So let's do a quick recap before I go ahead and show you how to do this. So let me go ahead and iterate over each of the values in L. So I can say things like for val in L, let me first print the val, and instead of printing the val, if I print val dot upper, as you can see, that's the most commonly used way for the method invocation, which is string variable name dot and then the method call. Recall that there is one other way to invoke methods actually, which is the roundabout redundant way. Instead of saying val.upper, you could say str.upper of val, which is pretty much going to do the exact same thing. So in order to pass a reference to a method, we need to use this second type of method invocation. So instead of just mentioning upper, I need to mention where the upper method comes from, which is defined as part of str. So if I go ahead and run this, and let me actually print vals after the transformation, as you can see, I'm able to successfully apply a string method as well and pass a reference to the string method as part of the function call to apply to each. All right, so instead of defining your own version of this apply to each function, I'm going to actually show you a Python function which is called map, which pretty much does the exact same functionality. Suppose, let me actually go ahead and tell you what the parameters for map are. So the first parameter is actually the function name that you want to apply. So suppose I want to take the initial example with this particular list, and let me actually go ahead and redefine the list, and I'm going to actually have two parameters for map. So the first one is the function that I want to apply, which is the int function, and the second one is the actual list. So let me go ahead and run that. So as you can see, it returns map returns some form of an object. It actually returns a generator, which is going to be the topic for the next lecture. For now, all that you need to know about generator is you will be able to typecast the generator to a list. So let me go ahead and do that, and if I rerun that particular cell, as you can see, map function does the exact same functionality as the apply to each function over which we just defined. Alright, so I'm going to actually switch back to the slides, and let's talk about the second usage that you can think of for function references, which is going to be sorting. So here is an example actually. So I have a list called names, which contains 3 tuples. Quick recap, a tuple is nothing but a list, but it is an immutable list. It has all the features of a list, but you cannot mutate the tuple entries. So you have 3 different tuples for 3 people's names. So what would happen if I call the sort function on names? We haven't actually discussed uh, sort using such complicated structures. So far we have covered how to use sort on a list, and what else have we done? We've used sort on a list of integers and on a list of strings, and we've looked at how comparison works and how sort of puts the items in order depending on what sort of type you have for each of those items. Alright, so let's go ahead and discuss what sort function call does for a more complex structure like a list of tuples. So sorting always works on the very first element given a tuple. So in this particular case, as you can see, that's gonna be the first name of the person. So if you try to invoke the sort function, an unordered tuple list of tuples will now become an ordered list of tuples based on the first element. So you're going to get the order as Alice, Bob, and Catherine ordered by this first character of each of those strings in alphabetic order. So what if we want to sort by some other field, let's say the last name here, for instance? How do you achieve that? Or what if we want to sort by the length of the name, in which case you want your sorting to be the smallest first name first, which would be Bob, and the next one would be Alice, and the last one would be Catherine, right? How exactly can we perform these different sorting operations that we need? So one way that we could think of solving this problem is, writing a sort function of our own, custom sort function of our own from scratch. But I can tell you that sorting is actually pretty complicated, and it will take a lot of effort to be able to write an efficient sort function from scratch for custom purposes. So how are we going to achieve that purpose if we are not going to write sorting code? So the way that we are going to do that is we are going to actually leverage a parameter defined as part of the sort function, a parameter which is called key. So this key parameter actually takes in an object to one other function which is supposed to return which field you want the sorting to be done by, or like how exactly, what is the factor for doing the sorting. For instance, uh, going back to the first question which we had, how do we sort this list of tuples by last name instead of by first name, is by defining a function called extract. And the function extract is going to take a name tuple as an argument, and what we want to do in this particular function is we want to return whichever field that we want to consider for our sorting purposes, which would be name tuple of 1. So if we go ahead and run names.sort with the key option, you'll see that it actually sorts the names by last name, which is going to or be ordered by Adams, Baker, and Clark. All right. So to answer the second question, how do we sort based on the length of the first name, for instance? What you can do is the extract function can now just return length of name tuple of 0. So if you go ahead and do that, then your sorting actually gets applied to the length of the first name. All right. So let me go ahead and go back to my Jupyter notebook, and I'm going to show you a demo of how exactly we can use this sort um, sort custom sort that we just covered. So let me go ahead and define a list for hurricanes. So I'm actually going to define a list of dictionaries instead of saying I'll be defining a list of tuples. So we already saw an example with list of tuples. I'm going to talk about what's the difference between the list of tuples example and the dictionary over here. So suppose I want to define things like, okay, let me add a hurricane name, and let me add a hurricane year, and suppose if I add a hurricane speed. So let me actually make sure that there are different orders in this data set based on which field that we want to perform the sorting by. So, alright, so let me actually change the next hurricanes here to 1990, and let's say the third one's to 1980, and let's say I'm changing the speed to 150 and 250 here. Alright, so let me go ahead and demonstrate to you how what would happen if I called the sort function. Actually, let's do this. So since I showed you an example for the sort function call, let's actually do the sorted function call instead, so that we can have the original data intact. Sorted function call also has the same argument called key. So how exactly can you find out you know details of such argument? For instance, you can just Google Python sort built-in documentation. So if you go to the built-in functions documentation and search for sort or sorted, let me go ahead and click sorted. You should be able to get to the documentation for this particular function. As you can see, there is a key option, and there is also another option called reverse. You should be able to read through the specification and learn new parameters to functions, which are very helpful. Alright, so let me go ahead and invoke the sorted function using hurricanes, and we'll see what exactly happens. So you're actually going to get an error if you invoke the sorted functions with hurricanes. Unlike the tuples example, you'll receive an error instead of the sort working based on this name field over here. So the reason for that is dictionaries are supposed to have no particular order, right? So which is preventing sorted from picking and choosing one particular field. So there isn't like a first field when it comes to dictionary. That is why sorted is not able to pick and choose one field, and that's why you're receiving this error. Alright, so the way that you can overcome this error is once again by defining your own custom function, which is going to tell you which particular column that you need to sort by. For instance, let's try to write a get year function which takes one hurricane, and given a hurricane it would return the year during which that particular hurricane occurred. And what you can do now is, instead of just calling sorted of hurricanes, you can just pass get underscore year year the uh, as a parameter to the named keyword get underscore year as an argument to the named keyword argument key. So let me go ahead and run the function now. So as you can see, it's actually sorting the hurricanes by year. So you get 1980 first and 1990 first and 2000 last. And you could also try out the reverse option. So the default for reverse is actually false. So if I go ahead and pass true to it, as you'll see, it will actually do the reverse sort, which puts 2000 first and 1990 next and 1980 later on. So if you try to, let's say, let me go ahead and switch uh, these two entries in my hurricanes list so that we can see whether the reverse actually works. So it seemed to work fine. So as you can see, the order now is hurricane A, C and B instead of A, B and C. Alright, so I'm going to go ahead and remove the reverse option. You can play around with it later. Alright, so couple of things to consider here. So what if you want to sort by a different field? So the way that you can achieve that is by defining another get function. Let's say I want to sort by speed. So I'll be returning hurricane of speed. So let me go ahead and capture this return value. Let me actually add that to a separate cell so that we can actually look at what's happening. Right, so let me go ahead and run that. So as you can see now, the function is actually sorting based on speed, the sorted function, and you get the hurricanes ordered by the speed, which is BCA. Alright, so that is the first thing which I wanted to mention. The second thing which I wanted to mention is what if a particular field is not defined. Uh, so mainly to do with the fact that data sets are not complete. Suppose you don't know a speed of a hurricane. So let me go ahead and do that. Suppose we don't know the speed of this particular hurricane, for instance. So what can we do in that case? So let me go ahead and remove. Let me go ahead and actually redefine hurricanes inside the cell so that we can manipulate the data a little bit. So let me go ahead and remove the speed for the third hurricane. And okay, so what just happened? Okay, so oh, okay, sorry about that. I am actually invoking the wrong function, unfortunately. I was like, okay, why is that not giving me an error? There we go. Okay, sorry about that. So if I go ahead and pass the correct function reference, as you can see that now the sorted function is complaining, saying it cannot sort the hurricanes. So I want to quickly show you how you can read this stack error stack over here. So let's see what cell has the problem. So as you can see in my notebook, cell number 37 has an error in line number 10. So just to do a quick recap, you can view line numbers by going to view toggle line numbers. So let me go ahead and switch that again. So make sure to have your line numbers turned on. So it's complaining about line number 10, which is the sorted function call, right? So what is the stack giving me after that? It's going ahead and giving me, okay, inside the get speed function, which particular line is giving me the error, and it is saying that line 8 is actually giving me the error. Line 8 is this. So what's happening? So clearly I'm trying to get the value which corresponds to the key speed. Don't get this key parameter confused with the actual key value of a dictionary. So in this key reference, I'm talking about the fact that speed is the key which we are interested in as part of this particular dictionary. So clearly for this dictionary, there is no defined key called speed. So recall that you can use the get function instead of the regular key based lookup. And if you do use the get function, let's say you can pass the default value. So since the speed of this hurricane is unknown, I'm going to go ahead and assume that the speed is 0. sort of a decent assumption, right? Because we know nothing about the speed of that particular hurricane. So if I go ahead and run the code now, as you can see, it assumes that speed for hurricane C is actually 0. So that comes before the other two hurricanes. We can go ahead and confirm that by saying the reverse keyword argument is true, and as you can see, it flips over the whole thing. Hopefully that makes sense. So you can handle missing data by using use by using the get function call instead of by looking up based on keys. All right, so one last thing which I wanted to show you is let me show you an example of how to combine the sorted method sorted function call with a method. So let's say I want to sort you know uh, a list of strings which have like both smaller case letters and capital case letters. So what would happen, let's see what would happen when I go ahead and do this. So recall that in Python, capital letters actually come before the small letters, and that's why this is gonna return a capital A, C, and then small b and d. What if I want to fix this and I want it to be able to deal with this case difference while performing the sorting? So the way that I can do that is for the key named parameter, I can just pass, let's say, str.upper method call. If I go ahead and do that, as you can see, let me actually leave this in a new cell so that it's quite clear when you go through the code. All right. So as you can see now, the sorter function is able to properly accommodate the fact that we want the sorting to consider both upper cases and lower cases. Hopefully, all the topics about functions as objects makes sense. Uh, I will be recording the next lecture soon. Before that, I just want to quickly show you where you can find each of these video lectures. So let me go to the course website. So as you can see, I've created a dummy link for today's lecture, which is going to be on function references. So along with the code link, now we'll be posting the lecture video link as well. Hopefully you should be able to follow all the lectures and do ask us any questions during office hours or on Piazza. Alright, I'll be posting this code after I post this video lecture as well. Alright everyone, stay healthy and take care of yourself and try to stay positive and happy. Uh, I'm sure we all can get through these difficult times.